Imagine waking up in 2026. You reach for your phone. It was made by Apple. The chip inside was designed with software running on NVIDIA hardware. The app you open is powered by Google. The cloud storing your data belongs to Amazon or Microsoft. Before you have even left your bed, you have touched the infrastructure of 5 empires. This is not a coincidence. This is architecture. Deliberate, calculated, generational architecture. For the past 3 decades, a handful of companies have been quietly building something that has never existed before in human history. Not countries, not governments, not armies. Something far more pervasive. Something you carry in your pocket, plug into your wall, and invite into your home. They built the operating system of modern civilization. By April 2026, the combined market capitalization of the top technology giants on this planet is approaching somewhere between $15 and $20 trillion. That number is almost impossible to comprehend. It is larger than the GDP of every country on Earth except the United States and China. It represents more concentrated economic power than anything the ancient empires of Rome, Persia, or Britain ever commanded. And yet, most people interact with these companies every single day without ever stopping to ask the most important question of our time. This is the story of the titans of 2026, the architects of the global machine, the men and the companies that did not just participate in the future. They wrote it. Let's start with NVIDIA, the AI arms dealer. There is a Denny's restaurant in East San Jose, California. It looks like every other Denny's in America. Booths with cracked vinyl, coffee in styrofoam cups, fluorescent lights humming overhead. But in 1993, something happened inside that unremarkable diner that would eventually reshape the entire world. 3 men sat down for breakfast. Jensen Huang, a 30-year-old engineer with a background at AMD and LSI Logic. Curtis Prame, a chip architect from IBM. Chris Malachowski, another engineer who had spent years at Sun Microsystems. They had a single idea: graphics. Specifically, they believed the market was ready for a dedicated chip that could handle the complex mathematical workload of rendering images on a computer screen. They called their company NVIDIA, and they had absolutely no idea what they were actually building. In the 1990s and early 2000s, NVIDIA was a graphics company, pure and simple. Their GPUs, or graphics processing units, were the holy grail for gamers. The GeForce line became legendary. If you wanted to run Quake at full resolution, you needed an NVIDIA card. If you wanted to render a Pixar-quality frame on a consumer machine, you needed an NVIDIA card. But here is the thing about GPUs that nobody fully appreciated until much later. They are fundamentally different from the standard central processing unit, the CPU, that runs your computer. A CPU is like a brilliant surgeon. It performs complex tasks, one after another, with extraordinary precision. A GPU is like an army. Thousands of smaller processors working simultaneously, in perfect parallel. For gaming, this meant more pixels, more frames, more visual detail. But for something else entirely, it meant something world-changing. Training an artificial intelligence model requires doing the same mathematical operation over and over again, billions or even trillions of times. Matrix multiplications, gradient calculations, backpropagation. The math is not particularly complex in isolation, but the sheer volume of it is staggering. And that is exactly what a GPU is built for: massive, parallel, repetitive computation. Researchers at universities and tech companies began to notice this around 2010 and 2011. A landmark moment came in 2012 when 2 graduate students at the University of Toronto, Alex Krzyzewski and Ilya Sutskever, used NVIDIA GPUs to train a neural network called AlexNet. It absolutely crushed the competition in a global image recognition contest. The AI research community took notice immediately. Jensen Huang took notice too. NVIDIA was already building chips for graphics. The architecture was already suited for AI. What followed was one of the most deliberate and visionary corporate pivots in modern business history. NVIDIA began designing chips specifically for AI workloads. The CUDA software platform, which allows developers to program directly on GPU hardware, became an industry standard. Entire ecosystems of AI tools, research libraries, and enterprise software were built on top of CUDA. Switching costs became enormous. By the time competitors realized what had happened, NVIDIA had built a moat so deep it was practically a canyon. Then came the large language model era. ChatGPT launched in November 2022, and the world lost its mind. Every company on Earth suddenly needed to train AI models. Every government wanted to build sovereign AI infrastructure. Every university, every startup, every hedge fund wanted a piece of the intelligence arms race. And they all needed the same thing: NVIDIA chips. The demand became almost incomprehensible. Data centers that would have taken years to plan and build were being rushed online in months. Companies were not just buying chips, they were panic buying chips, placing orders years in advance, paying premiums, getting on waiting lists. Jensen Huang became arguably the most important person in the technology industry, not because he invented artificial intelligence, but because he controls the factory that makes the shovels for the AI gold rush. The latest generation of NVIDIA chips, the Blackwell architecture, represents a generational leap in computing power. The Blackwell chips are designed specifically for the demands of modern AI inference and training. They are not just faster than their predecessors. They are built differently, from the ground up, for the age of large-scale intelligence. The numbers that followed are almost surreal. NVIDIA reported fiscal year 2026 revenue of $215.9 billion. That is not a typo. $215 billion. From a company that, in fiscal year 2023, reported revenue of just under $27 billion. In 3 years, NVIDIA's revenue grew by nearly 8 times. It is one of the fastest wealth creation events in corporate history. The global shortage of compute power is not a temporary supply chain hiccup. It is a structural feature of the AI age. The demand for intelligence infrastructure is growing faster than any company, including NVIDIA, can manufacture the chips to meet it. Countries are building national AI strategies around access to NVIDIA hardware. The chip has become a geopolitical asset. Jensen Huang once said that the more you buy, the more you save. In 2026, the entire world is buying. And NVIDIA is collecting the toll on every single road that leads to the future. Part 3. Apple the Walled Garden. There is a house at 2066 Crist Drive in Los Altos, California. It is modest by Silicon Valley standards. A single-story ranch house, a 2-car garage, fruit trees in the backyard. Most people drive past it without a second thought. But inside that garage, sometime in 1976, Steve Jobs and Steve Wozniak assembled the first Apple computers by hand. Wozniak had designed the circuit board. Jobs had the vision for what it could become. They sold their first 100 units to a local computer shop at $666 apiece. Apple Computer was born. What followed is one of the most dramatic corporate stories ever told. The Macintosh, the graphical user interface, the mouse, the idea that computers could be friendly. Apple went public. The stock soared. Jobs graced the cover of Time magazine. And then, in 1985, he was pushed out of his own company. The decade that followed was a slow, grinding disaster for Apple. By 1997, the company was 90 days from bankruptcy. Its products were a mess. Its strategy was incoherent. Its market share had collapsed. The press had already written the obituary. Then Jobs came back. What happened next is the single greatest corporate turnaround in history. Jobs killed hundreds of products and focused on four. He introduced the iMac, the iPod, the iTunes Store. And then, in January 2007, standing on a stage in San Francisco, he told the world that Apple was going to reinvent the phone. The iPhone was not just a better phone. It was a new category of human experience. A pocket-sized computer with a multi-touch screen, an internet connection, and a camera. It was designed with an obsessive attention to detail that bordered on the pathological. Every corner radius, every icon, every animation was debated and refined until it felt inevitable. The iPhone did not just change Apple. It changed every industry on the planet. Publishing, music, photography, navigation, banking, retail, medicine. The iPhone created a new economy around itself. Millions of apps, billions of developers, an entire ecosystem of accessories and services. And crucially, Apple built walls around all of it. The App Store, launched in 2008, was a masterstroke of platform architecture. Every application on an iPhone had to be approved by Apple. Every digital purchase made on an iPhone flowed through Apple's payment systems. Apple took a 30% cut of everything. Not because they had to, because they could. Because they owned the platform. The walled garden is not a metaphor. It is Apple's entire business strategy. Make the hardware beautiful. Make the software seamless. Lock the two together so tightly that leaving feels like amputation. Once you are in the Apple ecosystem, the friction of leaving becomes enormous. Your photos, your messages, your contacts, your health data, your payment information, all of it lives inside the garden. All of it reinforces the lock-in. By the first quarter of 2026, Apple reported revenue of $143.8 billion in a single quarter, more than many countries earn in an entire year. There are now an estimated 2.5 billion active Apple devices in the world. iPhones, iPads, Macs, Apple Watches, AirPods, Apple TVs. 2.5 billion entry points into the walled garden. 2.5 billion monthly opportunities to sell a subscription, a service, an upgrade, a download. The newest frontier is Apple Intelligence. Apple's approach to artificial intelligence is characteristically Apple. Not the fastest, not the most powerful, but the most carefully integrated. Apple Intelligence runs directly on device, processing personal data locally rather than sending it to the cloud. It threads through every Apple application. It writes emails. It summarizes notifications. It edits photos. It makes the hardware feel alive in a way it never quite did before. And it gives Apple a reason to sell its next 2 billion devices to the billion people who do not yet own one. Then there is the Vision Pro. Unveiled in 2023 and refined through 2024 and 2025, the Vision Pro is Apple's bet on spatial computing. The idea is simple, even if the execution is extraordinarily complex. The physical world and the digital world should not be separate. They should coexist. They should blend. They should feel like one continuous reality. Apple calls it the era of spatial computing. Critics call it expensive and premature. But those same critics said the same thing about the iPhone in 2007, and about the iPad in 2010, and about the Apple Watch in 2014. Apple has always been willing to be early, because Apple understands one thing better than almost any company that has ever existed. People do not know what they want until you show them. And once you show them, they never want to go back. Part 4. Tesla, the Physical AI. In 2004, a group of engineers in Silicon Valley decided to build an electric car. Not a concept. Not a prototype for a show floor. A real car. One that people would actually buy. The problems were enormous. Electric vehicles had existed for decades, but they were slow, ugly, and had terrible range. The battery technology was primitive. The charging infrastructure was non-existent. The auto industry, a 100-year-old cathedral of entrenched interests, had absolutely no intention of changing. Then Elon Musk joined as chairman and lead investor. Then he became CEO. And then the story became something else entirely. The Roadster, Tesla's first car, was supposed to launch in 2006. It actually launched in limited form in 2008. The development process was a nightmare. Cost overruns, engineering crises, supplier failures, public feuds. Musk later described the company as being weeks away from total collapse multiple times during the Roadster development. But the Roadster worked. It proved the concept. An electric car could be fast, beautiful, and desirable. The Model S followed in 2012. The Model X in 2015. The Model 3 in 2017. The Model 3 nearly killed the company. Musk called it production hell, and he was not being dramatic. He famously slept on the factory floor in Fremont, California. Tesla was burning through cash faster than it could raise it. Short sellers were circling. The financial press was writing obituaries. At one point in 2018, the company's survival was genuinely uncertain. But Tesla survived. Then it thrived. Then it became the most valuable car company on the planet. Not because it made the best cars, but because it made people believe that the future of transportation had already arrived. By the first quarter of 2026, Tesla reported revenue of $22.4 billion. That number tells only part of the story. Because by 2026, asking whether Tesla is a car company is like asking whether Amazon is a bookstore. Tesla is a physical AI company. Every Tesla vehicle on the road is a data collection device. Cameras, sensors, and neural network processors gather information about real-world driving conditions 24 hours a day. Millions of cars. Billions of miles. An incomprehensible data set of how the physical world works. This data trains Tesla's autonomous driving systems in a way that no competitor can replicate. Because no competitor has the fleet. The Cybercab, Tesla's purpose-built robo-taxi, represents the company's most aggressive commercial bet. It has no steering wheel, no pedals, no provision for a human driver. It is designed from the ground up to operate autonomously, 24 hours a day, 7 days a week. It does not need to sleep. It does not need a salary. It does not need health insurance. It just drives. The implications for urban transportation are staggering. If Tesla deploys cybercabs at scale, it would not just disrupt Uber and Lyft. It would fundamentally alter the economics of car ownership, urban planning, and human mobility. A personal vehicle sits parked 95% of the time. A robo-taxi fleet never stops earning. But even the Cybercab is not Tesla's most audacious project. That is Optimus. The Optimus humanoid robot is Tesla's attempt to solve one of the hardest problems in all of engineering. Building a machine that can navigate the physical world as fluidly and flexibly as a human being. Not a specialized robot that performs one task on an assembly line. A general-purpose robot that can load boxes, sort packages, care for patients, assist in construction, or perform any task a human hand can perform. Tesla claims it will eventually produce Optimus robots in volumes that rival its car production. Millions of robots. Trained on the same AI infrastructure that powers the cars. Learning from each other. Improving constantly. Musk has said that Optimus could eventually be worth more than every other part of Tesla combined. That is a breathtaking claim. But then again, he said the same thing about self-driving cars in 2016. And the world is still waiting. The difference in 2026 is that the waiting feels much shorter.